Hello everyone, welcome to today's lecture. In our today's lecture, we are going to learn about the network forwarding. Yes. So, a forwarding is simply defined as the action applied by each router when packet arrives at one of its interfaces. Till now, we have seen that the packet is when packet is sent by the sender, then that packet is routed through multiple routers, and that routing path is defined by the routers. But when after at the end of the last router, when the message received at the last router, now it is sent to the receiver. So here the forwarding is simply an action which is applied by each router when packets arrives at one of its interfaces. Yes, so when the packet is arrive at the destination, then what action we are applying on that, so that is called the forwarding. When router receives a packet from one of its attached networks, it needs to forward the packets to another attached network. Yes, so suppose sender A sends a message to the host B. So in between there are 5 routers are there. So first it start traveling from the host PC, then it route through the route on the network and received at the router A. When router receives a packet, so then it needs to forward packet to the another network, because the path is already defined. Yes, so when packet is received at that particular router, so it's now responsibility of that router to do some action on that, do some forwarding. So it forwards that packets to the another router. Suppose we are sending one letter via courier. Yes, so when it courier is traveled through multiple routes, but the destination is suppose Ahmedabad and the source is Bhavnagar. Yes, but courier service first travel to Baroda, and then Baroda to Ahmedabad. So when the courier is reaches to the Baroda, now the Baroda's office, now it's responsibility of that Baroda's office to forward that packet to that particular address, that particular next router. Yes, so this is how the network packet is also forwarded through one router to another router. When a host has a packet to send, or when router has received a packet to be forwarded, it looks at this table to find the route to the final destination. So when it is reaches to one particular router, then there is one route table is maintained in which all the routing information is stored. So it just look at that table and find the next route for the final destination. So now you see that the next is suppose Anand. So now that courier is now travel to Anand, and then reaches to the Anand, and now at Anand destination it also see what is the next route. So now from Anand it reaches to the Ahmedabad. So this is how physical routing is done, and same as in the network, it see the different routers address on the from router table, and that is how it reaches to the final destination. However, this simple solution is impossible today in the internet networks such as internet, because the numbers of entries needed in the routing table would make table lookups inefficient. Yes, suppose if there is only 3 routers connected in the network, then it is very easy to find the routes. Yes, and it is very easy to look up on the router table. But nowadays, due to inter-network connection, there are lots of network devices, lots of router points are connected on the network. Yes, so so now if you are looking on the router table, then it is very difficult to look up on the table. Yes, and also due to there is many entries in that, it needs some time also. So so it makes table lookups inefficient and very difficult. So for that, different routing techniques are there. So the types of forwarding techniques are next hop versus route method, network specific versus host specific method, and default method. So let's start with the first method. So the first method is a next hop, while here next hop versus route method means route method is our traditional method in which we are finding in the routing table. Here the technique for forwarding is the next hop technique. So on this technique, to reduce the content of routing table is called the next hop method. In this technique, the routing table holds only the address of the next hop instead of information about the complete route. We already seen our previous lecture that routing contains complete address of from source to destination. If source, then which are the routers on which the packet is visited, and at the end the destination is reaches. So that whole path is stored in the routing table. So it makes routing table too heavy. Yes. So in a next hop technique, we are just storing the address of only a next router rather than storing the complete route of the storing the complete route. So the entries of routing table must be consistent with one another. So this is the next hop technique for forwarding, in which we are only storing the next router's address. So this is a figure. In this figure, let's assume that this host A wants to send message to this host B. So in which there are two routers is there, and this two routers is connected on the internet. So via these two routers, the network is via these two routers, the packet is assigned over the network, and this two router forwards this packet to the destination host. So this is a traditional technique, routing table based on route. So this is a traditional technique in which here it is written that the destination is host B and the route is R1, R2, then host B. So here the complete route information is shown. While in the next hop technique, it is said that the destination is host B and next hop is R1. So here we are just storing the information of next router only. When it reaches to the R1, then destination is host B, next hop is R2. So after this, only this information of router R2 is stored. And after reaching to the R2, it said that now the next destination is host B. So this is how the information of routing table is stored. While in the routing table, whole route information is stored. So this is this makes routing table so bulky. So this is how next hop technique is useful. Second technique is a network specific versus host specific methods. So a second technique to reduce the routing table and simplify the searching process is called the network specific method. So in this network specific method, routing table holds only one entry that defines the address of destination network instead of all hosts on the network. It does not store all the host or routers information, it just stores the destination. So this is the figure in which this is a network N1 and through which this sender is connected, and this network there are multiple computers are connected. So in the routing table for host S based on host specific method, here destination next destination is A, the next hop is R1. If B, then R1, C, then R1, and D, then R1. If want to reaches to the A, B, C, D, then the destination next router is R1. So that all information is stored in the host specific method. While in the network specific method, here this N1 and N2, it just store that if you want to reach to the network 2 and connected devices on that network 2, you need to you need to pass through the router R1. So next stop is R1. Here this makes it bulky because A, B, C, D all are connected with network N2. So if you want to reach to one of these hosts, then you need to reaches to the network N2. So if we find the simple way that if you want to reaches to the network N2, then the route is connect through the router R1. So here we are just only storing the destination network and next route. So this is a very easy method. So we can remove the multiples host information from the routing table. So this makes our routing table light. So host specific routing is used for the purpose such as checking the route or provide security measures. So if you need these types of features, then host specific routing is used, but if you don't want these features, then network specific routing is very useful. Now the third method is default method. So another technique to simplify routing is called the default method. Host A is connected to a network with two routers. So here in our previous example we have seen that the host is only connected with the one routers, but in the default method host is connected with two routers. Router R1 routes the packets to host connected to network N2. However, for the rest of the network, router R2 is used. So instead of listing all networks in the entire internet, host A can just have one entry called default, which is already 0.0.0.0. So as seen in this figure, this host is connected with this two router R1 and R2. Yes, now R1 is only connected with this network N2, and the router R2, which is called default router, is connected with the rest of the internet. So in the destination, if it is a network N2, then we can directly do with the R1 also, and we can use this R2 router, and this is connected with the rest of the internet. So via this multiple routes we can reach to the network N2. So this is how the default method is for. So all these three techniques, next of network specific and default method, are the techniques for the forwarding. So this is all about forwarding. Thank you so much for listening. Have a great day.